Good afternoon, everyone. I'm Sudheer from IIT Bombay. I'm pursuing my PhD. I'm focused on workers and their fatigue. So this is a parallel work in my research. Uh, this is an empirical study on the action recognition of workers in the sites. So for that, we started uh, reviewing the existing action recognition models. And when we compared them with the one-dimensional data, that is the signals from any of the EEG, EMG sensors, uh, people do study the window length, what is the context which is relevant to the actions or the data, how they can better interpret the data. But in vision, the videos, whatever video clips we take up, such window lengths are not usually taken care of. We assume we are able to understand this is the action length, but we don't see how well the models understand the same actions. So for that, I looked at only this feature window size, and I considered that to be the clip length, which I'll use the terminology repeatedly. Uh, in existing literature, I looked at the clip lengths of the data sets which are available, both in construction as well as the computer vision data sets. These two on the right, they are AVA and kinetics data sets. And the other two on the left, one is by the author who's already here. So this shows the clip lengths of the data sets which are available. In one data set, the clip length is around 7 seconds on average. In the other, it's around 2 seconds. So what happens is when we go for a transfer learning sort of approach, you train your model in one data set and you go for field. The clip lengths, if they don't match, the learning, whatever we learned, it will not be useful for us. So again, I focused back onto the models. So I started with creating a data set. First, we took up some videos from YouTube and annotated them. But here the annotation is focused on Kinetics 400 dataset. The Kinetics 400 dataset doesn't have all construction tasks. So we annotated the closest classes which we can relate to. Then we use the same models which are pre-trained on Kinetics 400 dataset. And we use them to run inference. And we use both of these annotations and detections for evaluation. In evaluation, we had two steps. One, the type of evaluation. We looked at the frame-wise evaluations, sequence, and the inference durations. And when we are going to discuss, we also looked at whether we are considering the full dataset or activity-based dataset. Some more details about the models which we took up. We use the action toolbox, and we use the kinetics dataset which is existing, and the models which are best performing on them. So these three are the models: I3D, MViT V2, and VideoMAE. These three are completely different, as you can see in the type. I3D is a CNN-based model, and it has inputs in video directly, whereas MViT V2 is trained on image dataset, and it is a transformer-based model. And the VideoMAE V2 is a transformer-based model, but it takes in input of video. With these three, we wanted to compare whether CNN or transformer works better and whether video input or image-based input works better. Some more details about the evaluation. Consider this to be the clip. We took a clip, and then actual tasks can be task 1, 2, 3, and all. But we annotated according to Kinetics 400 dataset classes, and we expect the models to predict them. We looked at the vertical direction frame to frame. That is the frame-wise accuracy, where we looked at total positives out of total predictions. And then in the horizontal direction, we looked at when there is a class change, class 1 to class 8, whether the model is predicting a change or not. Because there is a difference between human perceiving the kinetics dataset and model perceiving the kinetics dataset. So we are just looking at whether there is a change or not. We don't need the exact change. So that's how we looked at the sequence predictability error as well. Some more details, we looked at the clip length, that is the duration of the clip which we are going to input. We looked at 1, 3, 5, 7, and 9 seconds. But we also added two other variables: overlap length between the consecutive clips and gap between consecutive clips. We used these combinations, and we took around 22 combinations for them. In my previous practice, I found out that when I go into results, I'm not going to complete in 8 minutes. So an overview, we looked at frame-wise, and we found out three major activities to be better performing. Okay, I'll mention from here itself. So three activities worked very well. And then in sequence wise, we look at there are changes when we increase the sequence length, clip length, and even overlap and gap lengths. Then in the inference durations, we find out that I3D, the CNN based model, when we increase the clip length, they are going to take even more time for inference. So they are slightly less effective than transformer based models. Then finally, when we looked at task wise also, there are some problems which we found out, and I'm going to go into the discussion as well and then discuss the same things again. In a shorter summary, transformers outperform CNN models. That's why everyone is going into them. But video trained models outperform image trained models. So it's preferable to use video based models for action recognition. And particularly when we look at CNN based models like I3D, it's better to have longer clip lengths. It's like 5 seconds or 7 seconds worked well for us. And VideoMAE shorter clip lengths worked well for us. We were able to improve the accuracy for giving some repetitive gaps for the repetitive actions. Like in our data set, which we took, the excavation and masonry, they are too much repetitive. And when we found out the gaps, even when we gave the gaps, it was working well. And the overlaps for actions are good when there are some heavy variations between the tasks. So if we want to prioritize speed, you can use video-based models with shorter clip length. And if you want to use, prioritize the sequence changes, you can use image-based models. This is based on the overall evaluation, and the next part is the task-based evaluation, where we looked at the data set which we use, the Kinetics 400. There are only three major classes: the excavation, masonry, and plastering. These classes, all the models were performing very well, but the other classes, no model is performing good. So the other activities like concreting, formwork, scaffolding, we need some more data sets so that we can train our models better. And relating to the sequence predictability, all the models are having negative sequence predictability. That is, they are not predicting the changes correctly. So in essence, we are able to detect change in the actions, but models are not. So we have to take care about them, and we can improve predictability for I3D MViT by taking longer clip lengths. But MViT didn't work. These task specific clip lengths are very necessary for each of these tasks, like the excavation or masonry. We take its own specific clip length and they will give better performance. So it's better if we focus on each activity and take the specific clip lengths. And finally, if you want to prioritize accuracy, use activities which are available in the pre-training data sets only. Use longer clip lengths and check and provide for overlaps and gaps as per your requirement. Limitation wise, we didn't explore the effect of noise and occlusions in the data set which we collected. And the sequence predictability metric which we created, it doesn't exactly capture where the change happened. In the overall video, there can be changes at some other points we tagged, whereas the model tagged at some other points. So the temporal bounds, which we also call it as action segmentation, that method would have been better. Future work, we can look at execution time varying data sets by manually varying different times for the same actions, create a data set. And we can explore other options, like there are much better data sets like AVA kinetics together, and then other modalities architectures. In conclusion, this study examined how models and clip durations affect action recognition. Key takeaways: model choice does matter. Clip durations is task specific, and gaps and overlaps can improve accuracy. That ends my presentation.